So let's have a look inside. So first thing up, warranty seal. So again, the technique I'm stealing from Mike, of Mike's Electric Stuff, which is you take some sticker backing paper, which tends to be thin and fairly rigid, and it's also like wax coated, and you kind of just work it under the sticker. Alright, so this seems to have the same kind of general Rigol style that a lot of them have had, which is 2 torque screws there and 2 screws under the handle, which are annoying to get to. Oops, and there went all of my bits. Oh, hey, look. There's actually not a screw there. There's just a divot that looks like one. How nice of them. So, we are free. Except for the fact that apparently these screws aren't all the way out. It's hard to see. Oops. That's actually all the way out there. These appear to be going into metal inserts. It's kind of intriguing. Okay, whoops. Yeah, so that's interesting. So these screws are machine threaded. They've got a mixture. So here is our scope. So first thing that's readily apparent is that clicky power switch is actually straight up interrupting the mains. See, there we have mains power. It looks like they're only switching one of the 2 phases. They're only switching hot from the look of it, which is a little, I guess it's not a big deal, a little disappointing. Got the typical really solid. This is like, it's like 20 or 22 gauge. It's very heavy steel. It's not lightweight at all. As you can, it's not the right, yeah, that's the full edge thickness. Look how heavy this stuff is. There's our one fan. It's very well kind of encapsulated. So it looks like this whole back comes off once you've removed all of these screws around the perimeter, which are Torx. Also, interestingly enough, it seems like these are obviously the, I think these are the ARB function generator connections would go here. I don't know what would go there, if anything. Maybe that's just an option. I guess it makes sense to have the case punched for all of the potential things you might put in. Or maybe they even use the same housing for, excuse me, multiple products. Jerk free, I guess. It's a snug fit. Shazam. So, it's quite elegant. So we actually have a nice, very large power connector. And the fan actually appears to be connected to this board. It runs through this board rather than running a canned power supply. But it also looks like the power supply is an entirely standalone unit, or at least it's independently shielded. I have this nice little kind of silly cable clip. I don't know why they didn't just get a fan with a shorter lead, but whatever. So, here is our main board, and there's not much to look at. So let me change lenses and we'll look more closely. Okie dokie, so first thing that's immediately obvious is this big connector here, which is pretty obviously, considering this big hole here, this is for a logic analyzer option, which I guess they have not released yet. You can see here we have big differential pairs, so I wonder if this will have like an external pod of some sort, because I don't think that it would require differential pairs. So there's a big BGA land here, or footprint here, which is for presumably the FPGA that would handle the logic analyzer, and then here's a little FPGA footprint for SRAM for that. This all routes over to, we've got a big, probably 8-bit bus that routes over to this point here. So my guess would be that's the main, possibly that's the main processor. Hang on a second. Let's see if that heatsink wants to unclip without a lot of effort. Yeah, it's grease, not epoxy, which is nice. So, while I'm at it, actually, there is over here is a big, but that's the CPU. My MX283DVM4B with its own SRAM. I would bet this is an FPGA. Let's see, am I seeing any? Yep. Spartan 6. So that's the main FPGA. It looks like this only has one FPGA. So that is an XE6SL X25. And then I would bet so I would assume that's the main, like, handles the Infinivision stuff. And then over there we have some Hynix. I bet that's DRAM H5PS5162 GFA. And then up here there's even more, there's Cypress RAM. So I think this, we had these same chips in the 4000 series. I think this may be like acquisition memory, and that's like some sort of DRAM for working, or it might be the other way around. Here's another one of these big chips. We saw the same thing. There's actually two chips in here that have been lasered off. This, I believe, is the ADC, and this is like some sort of timing generator. Assholes. Other stuff. Here's some. That's interesting. There's a Winbond 25X40. Can't quite make it out. DV whatever. And anyway, that's flash. That's interesting. ARM 24 megahertz battery. Here's a 24 megahertz crystal. So this is probably the main application processor. Considering that there's a crystal driven off it, some sort of inductor. 1117 voltage regulators. H5PS51624 or 164 versus 162 blah. So that's actually the same SRAM part. That's interesting. They use it in several different places. Miscellaneous TANs. So here's power supply, EDP 2323. That's obviously a switch mode regulator of some sort, and you have two big power FETs here. Coilcraft FETs, brand name FETs, or excuse me, inductors, nice of them. There's another 1117. There's the connector for the fan, and a little bitty cute little transistor to control the beeper. Various stuff over here. TI and analog devices branded. This is another regulator of some sort. I don't see the Ethernet PHY. I wonder how much is on the other side of this board. And that looks to be mostly it. Over here there's just some, miscellaneous discrete logic. And then down there we have a National Semi 25AC3878. Not too sure what that is. But this is the trigger out pass fail out BNC. That's quite interesting. Look at that. There's a it's going through whatever that is to the case ground from the look of it. And then I think this is the display interface, and over here is the button interface, or maybe vice versa. Interestingly enough, under that it looks, actually let me lift that up, it looks like there's a PCI style edge connector, which I would imagine is probably for debugging. I know a couple places I've worked have used PCIe 1X connectors for like JTAG because it's such a convenient connector. Yeah, it's actually something else, but yeah, you have like a little pin header there, which I would assume is for some sort of, you know, in-circuit testing facility. Oops, that goes in right there. Whoops. Oy. It's hard to get in while watching the camera. I'll just use my finger. Looks like it just popped into place. Yeah, it did. They're actually not, doesn't look like they're necessarily using all those, or some other connect interface wires here. And those run all the way over to here. Look at that, hardware version 654.32.10, SP version 987. And then it looks like we have a whole pile of connectors here, which I would imagine are JTAG of some sort. Oh look, hey! Resistors to set various revs. Oh, I see what's going on. So this is 65432, or 65432 and 0. So this is 0000200. Interesting. So that's how the hardware revs are set, and the SP version are set as well. It's quite intriguing. So again, this kind of makes me think it's like clock generation of some sort. In any event, let's look under the can, which looks like it has some fold-over tabs. Okay. So, well, there's not the front end in here is actually quite simple. So I guess the fact that they don't need to do like 50 ohm termination makes their life easier. So, input, here's our input B and C. One relay only. Lots of little transistors. 3EM, 3EK, 3EM, 7AT. Another Cosmo relay. This might actually, I would strongly suspect that actually the reason I couldn't hear the AC-DC switching is probably because it's these devices, because I bet that's your AC coupling capacitor. 4053. We just have this part here, which is a P2742AK D6LO. And then obviously here's our differential pairs. Also you can see we have some nice differential pair length matching, probably because this is the longest length. So I'm not sure. They might. It looks like it's almost all discrete, which is intriguing. Obviously that's the exact same circuit across all 4 channels. It looks, I wonder if there's a lot of stuff on the other side. There doesn't seem to be enough there that makes me think they must have lots of chips on the other side. I was hoping to avoid taking the board out. Doesn't look like I'm going to be able to do that. Don't know. It's bolted into the case. I'm going to have to take the front panel off. Probably I will. Lots of little interesting little oddments. Do I see anything that looks like a land from the other side? I can't really see down in there well enough. But yeah, so there's not much in here. I mean, it seems like it's very... The design is quite, you know, Spartan in a nice way. There's a micro. I bet that's the Ethernet PHY, actually, now that I think about it, because I think I saw a similar part. Or it could be something else. That's an 8051. But I think I saw something like that on the other one, and it looked like that. Interestingly enough, we have a 1.25 and a 3.3 volt regulator here that are also not populated, which I bet are for the logic analyzer interface. I don't remember seeing the logic analyzer as an option on Rigol's site, which means it may be something they're going to produce but aren't yet. Which is kind of a bummer, because I probably would have actually gone for that. I could have used that. Though at this point I just use like a Sele logic. So it looks like they're no longer using the black fins, which are interesting. They've moved to freescale semi-parts. I think they use some form of Linux on these. I don't remember. But yeah, so actually, I guess let me take this off and put the other side on. Yeah, so I think I'm fine without putting more paste on here. There's a lot of paste on the heatsink. And this isn't going to be that effective anyways. It's not a very big heatsink. Yeah, I'm getting pretty decent coverage. Yeah, that's all pasted up again. So this is just a that way. You go under there, and you go under there. And we are reinstalled. Alright, so I would be really happy if the BNCs were not retained into the case. Oh, hey, look! I see screws down here. It looks like this one, I don't have to take the front panel sticker off. So yeah, I'll pull the case, this out of the case. Let me so that's nice of them. Maybe they watched my video and were like, ah, too much of a pain in the ass to tear down. Yeah, right. You rotate it so you're kind of lifting up around all the corners. So obviously we have plastic and metal encoders. And there we are. So it actually appears the LCD interconnect is actually somewhere under here. Actually, it looks like the LCD interconnect is right under this array of resistors. You can also see, this is the thing I like about the other one, where there's an actual sheet of glass. It looks like double-sided sticky tape, but there's a whole sheet of glass on top of the LCD, between basically the surface of the LCD and the thing that you can poke with your fingers. And I like that a lot. I think that's excellent design right there. Just because it makes the whole system so much more, resistant to any sort of, basically like people poking at it, because you always like to poke at the screen and, kind of point stuff out. Just looking inside, I can kind of see down in the edges. Like other nice touches, oops. Like look how they've got like rolled over sheet metal here so that this cable won't abrade. That's a really, let me lift it out. So you can see how they've like rolled this edge over just to protect it. I mean, those are just kind of like nice touches. So I am going to pull this board out. So actually, you've got some paper towels, so I can put the monitor down face forward on a paper towel to keep it nice and protected. Incidentally, 6-inch crescent wrenches, awesome. So nice for BNCs and stuff like that. So it's another one of their logos. They like their little PCB arts. I get that. I've kind of been PCB arty recently. I might stick some of the more interesting stuff. So the stuff I put on PCBs tend to be more like internet memes, lolcats. Maybe I'll stick some of the PCB pictures of some of the images and stuff I've done recently on here. Okay, so that's the board free. You can see here's the little cal outputs. Ground is the case and the other one goes through to the board. yeah. So I'm just putting down paper towel just to kind of... Man, the review and teardown for this just hit 32 gigs. Well, there might be something else on there, I'm not too sure. Man, I shoot in 1080p because I'm a nut. And man, it uses a lot of disk space. These screws are all quite nice. They have a flat washer and then an anti-shake washer and then the actual screw. So it's nice that they put all that stuff on there, you know. So that looks to be all the screws, I think, except the one that's between the two connectors. That's all of them except one of them. Oh, now it's loose. So you just come, oops. There we are. What are you caught on? Oh, of course, there's the LCD monitor cable. Which, am I going to have to take the LCD off? Yeah, it looks like I am. Okay, so it appears you have to disconnect the LCD first because there's not enough cable, which is irritating. So I will put 2 screws back in so I can flip it over. Oops, I guess it's time to wake up. That would also explain why my alarm clock didn't go off this afternoon, because it was set for this night. It is now 1:15 a.m. instead of p.m. Derp. So, yeah. So these are also Torx. One thing that I do appreciate is they're all the exact same size of Torx. Definitely makes my life easier. Yeah, you can see here's the fitting for whatever connector goes there. It looks like there might be an option for like a B connector up front or something, I don't know. But it does not appear there's an option for like a trigger input or something. Oh yeah, that's interesting. This actually does not have... Yeah, I noticed that this scope does not have an external trigger option. Also, apparently Sigma lens caps makes good screw containers. So, gently lift up, and yep, now we're now free. So there's our little LCD with our little glass panel taped onto it. That is entirely unbranded. Or, correction, it looks like there is a metal, folded metal thing that's on top of the LCD, because there's the actual LCD module, and then there's this, I wonder how it's held on. I suspect strongly there's tape or glue under these 4 indentations, which is mildly annoying. Because I'm not very tempted to try and take that off. I don't really care too much about who makes the LCD. Yeah, I'm just going to say fuck it. But you can see there is the connector for the LCD and one little ceramic intent. Oh, that screws up one is here. Okay, so freedom! And there's not much over here either. This thing's pretty Spartan. First things first, no shielding case over here, but then I guess it's not needed because you have this. So we have a great big Hynix device, which I would bet is the application program. You know, basically the flash. There's our Cal. There's a few devices. Let me change lenses again. So here we are. Hynix H27U1G8F2BTR. I would bet that that's the flash for whatever run, basically the operating system. There's our Ethernet interface, which interestingly enough does not appear to have a, I don't see any magnetics, which makes me assume this must be a mag jack, which it is not labeled. In fact, I don't see anything anywhere. There's nothing on any of the jack sides. But I would assume that magnetics have to be in the jack simply because I don't know where else they would be. That's fairly interesting. Look at that. There's our USB ESD protection right there. There's two little diodes. There are the bottom sides of that piece of that RAM and FPGA, which are just interesting. You can see the decoupling layout. I don't know what that is. RC16E11027. AD1117. Let me get the front panel out of the way. There are two input sections which just have more AD5207. That is an HA595. Is that a shift register? It's a TLO72. Geez. P27428X. And there's another 595. So now we're just onto the same thing over here. And then there's this big thing here, 26P26MAG3. I think that's a PAL. There's one of them per two channels, which is intriguing. And that's about it. Yeah, I mean, other than that, it's just rubber stamp channel. We look on the front, or excuse me, the back. So whatever these two devices here are, 25AC3878. That's all probably responsible for generating the trigger output. And I bet this is connecting to the case because that's where the ground is, and I bet this is ESD protection for this, because you can see we have this little network here. Actually, if we flip this over, you'll see one of the interesting things is it like folds over and it fits on both the bottom and the top side of the board. That's quite nice. But that's about it. One thing I will note is that it looks like all of the connectors, like all of the through-hole parts, have been hand soldered, and they're all kind of fluxy. I guess I would assume they must be using no clean flux because they're kind of just leaving it there. But I mean, all of the, everything, like the case, you saw the other side of the BNCs. It's all kind of, like just grody flux. I guess they don't post clean the boards, but then hey, I guess you can cal it out maybe. Or something, I don't know. But yeah, that's about it. And then the only other thing is the actual front panel itself, which is just, oh hey, there's a device on there. Well, one thing that's kind of interesting is if you look over in this corner, there is a something here, IVHINS, which is appear to be on. It's in the internal layers somewhere. I'm not too sure. I don't know if that means there are 6 internal layers, or if there's just 2 internal layers and each of those 2 groups is on one of the internal layers. But there's definitely, I mean, there's obviously, this is at least a 4-layer board. SHI-HUI. Is that Shi and Hui? Is that like English encoded Chinese? I don't know. Or Romanji? So that's for Japanese. I don't see any layer legend. Like that would be nice. Over here, here's that presumably debugging connector that I was mentioning. So yeah, actually now that I looked at that. So front panel, they're all fairly decent looking encoders. Metallic. Hang on. So here's the front panel. You can see we have LEDs and stuff over here. This board, the left-hand side board, is just completely passive, whereas this has a fairly large chip on it. One thing I am noticing again is that they're using flathead screws to go into just holes in FR4, which is interesting. It's not a great idea, but I guess it makes it centered, and if you don't care about stressing the circuit board around the edges of your holes because you've kept your traces back, I guess it would be fine. Another thing is there's a lot of screws holding these front panels on. Like, this thing's held on with 5 screws just for this little board, which is definitely nice. It means they really care about making it mechanically robust. So here we just have, that is an Alcatel Pro ASIC 3. So I guess that's probably just a, like, I wonder if this handles button scanning or something like that. A3P030. And then they've just hotbar soldered this down and then gooped it up with flux, which is interesting diodes there. Obviously, I think this, even this looks like it's possibly 4 layers. That seems kind of outlandish, though. No, I think it's only 2. But yeah, I mean, it's quite nice. You know, I mean, through hole and LEDs, and this is, I mean, this is a double-sided load. I mean, that's a lot of work for. I'm actually kind of surprised they didn't try and keep their costs down by using basically backfiring LEDs and putting these LEDs on the other side of the board, which would mean they'd only have to have a single-sided surface mount load. I guess maybe they panel it all up and they don't care, but because I mean, you could, I mean, the only thing on this side of the board are through holes and more camera reading. So the only thing on this whole side of the board is the LEDs and the through hole components. So if you swap this out to use, you know, reverse firing LEDs, you know, and then they'd shine through a hole in like a via, you could very easily completely get rid of all of the, you know, basically all of the surface mount parts on the side of the board, and then it would be a single-sided load, which would be considerably cheaper in production. I'm not sure why they didn't do that. It's possible they you know, this is paneled up with something else that also needs to be double-sided load, so the effective cost increase is basically negligible. Though again, it looks like they have basically the one primary board, and then they have these 2 auxiliary boards, which I would assume are paneled up together somehow. Go figure. But yeah, I mean, I guess they need all these screws because you have to press in on these, and if, you know, you press in it and they didn't have the center stand off, the board would probably go like wobble. I do wish they had put, these 2 encoders have D10s and these encoders do not. I wish they all had D10s, but that's just me. Anyways, reassembly. So that, actually, now that I look at it, this pad here doesn't connect to anything. That's very strange. Yeah, that's entirely non-connected. There's no insert there, or it looks like the insert was not installed. There's 2 holes there for something. Oh wait, that's, oh yeah, of course, that's where this is spot welded. So I wonder if they had a version that had the ground tab connected there with like a little bolt and nut or something weird. And then they instead decided to mount it to the case. So, there's our button membrane. Interesting, you can see it looks like, you can see how they have like a, it's a one, I guess it must be a one-shot mold, and they just inject different colored plastics in different regions, which is interesting. I didn't know you could do that. Well, I guess it makes sense. I just didn't know it was done like that. Injection molding is an entire field in and of itself. Alright, so back in. Buttons are pushable. Alright, so there's the front panel together. So now let's take a quick look at the power supply. Because I think Rigol, from their previous scope I've taken apart, I think they're doing all of their own. Where did these two screws come from? That's slightly worrisome. Oh, I know what these two screws are. They're case screws. Oh yeah, those are the two screws that... Oh yeah, I know what they are. Never mind. Just had a bit of an oh shit moment. I think they do their power supply design in-house at this point, which is kind of impressive. So unlatch that. Other things I strongly approve of. There's a connector here that I can't quite get out because I have no angle. So I think this is only like covered on 3 sides. I think there's nothing on the bottom. Yeah. So there's our little. Yep, this is a Rigol branded DC to DC. Look at that, isn't that adorable? Hot and cold. Oh. So, yeah, so we just have input, and here's our common mode, you know, base or filtering, power factor correction probably as well. Big capacitor, main switching device, 2 optos. I'm not too sure why there are 2 optos. Oh, I know why there are 2 optos. It's because, well, no, wait. This doesn't do sleep mode, so which is why they only have 1 transformer. So I don't know what the 2 optos are for, unless they have different loops. But I only, you know, and we just have, you know, possibly even, I think it might have active rectification, or these are just diodes, and then just a whole lot of, just oodles of bypass caps, series filters, and then more bypass caps. If we look over here, we have the Chinese symbol for the wire colors, which nobody understands. Oh, I know why they have this, because that's their AC trigger, because you see the AC trigger come through one of these. So actually up there it says AC trig, and this is fan. I don't see the control IC, which makes me think this must be surface mount load on the bottom side. And then here's our really, really nice, beefy, giant connector to ground to the chassis. That's well done. No complaints. The main cap on here is a Capzon branded, which is a little meh. So, yeah, actually this is a very minimal. That's literally the only device on here. So, that is a LD7S75. Make it out, but yeah, this is, I mean, look how simple this is. I mean, it's just straight through with diodes. Yeah, I think these two big devices, whoops, sorry, these 2 big devices are just TO220 package diodes, because you can see 2 of the pins are shared. So that's all that is. I mean, it's just straight up rectification. I don't actually so here's our AC. Oh, actually, hey, look here, it's labeled. So 50 hertz, I guess this isn't, I guess it's US capable, but no. Ground, 9 volt, 5 volt, 5 volt, so there's 2 pins for 5 volts, 2 pins for ground, 2 pins for 7.5 volts, another ground, 17.5 volts, negative 17.5 volts, another ground, negative 7.5 volts. So this segment here is, it looks to be our analog section power, and then here we have ground, 9 volt, 5 volt, 5 volt, and grounds. So I would assume, although interestingly enough, it looks like the negative, or the 7.5 volt is also quite high power, because they're using 2 leads for that as well. The negative 7.5 volts is not. Yeah, one of these big one of these big diodes appears to be on the 7.5 volts and the other one is on the 5 volt. I think the 9 volt's fairly low power. The plus and minus 17.5 volts are using these SMC or SMA package diodes, so it's a negative 7.5 volts and the 9 volt. And then the voltage feedback, which is right here here's some of our loop compensation devices, appears to be running over and it's probably tapping off one of these windings. Here's something that's interesting. Look at the nice trace layout here. So you can see here are our bypass capacitors. So the traces are big and fat, and they neck them down right around the bypass capacitor pins to just try and basically make it so the capacitors function more effectively by preventing current from flowing around them, if you will. It's kind of an imprecise way of explaining it, but that's functionally how it works. All these capacitors are, they're all cap X on branded. Whoever that is, caps on. They are 105 degree C rated though, which is nice. So let me here is, it looks like this device, whatever it is the main switching device. One thing that's interesting you'll see here is, we have spark gaps, which are accomplished by just pulling the solder mask back and using little Domokun teeth. Interestingly enough, they appear to be across they are across the common mode choke switch. This is kind of strange. I guess that's to prevent the common mode chokes from having too much common mode voltage across them, which seems odd. I guess that, hey, whatever works. Here are Y caps. I bet this is like a mauve. These are probably mauves. But yeah, that chip is a it's actually an LD7575. Hold on a second. It's an LD7575PS. And that appears to be the only active component entirely. It looks like it's whatever this is going on here is possibly related to driving it. We have 1R0. There's a 499 ohm resistor, and there's a 9311, so that's a 9.31K. So, yeah, I'm not too sure. And then it looks like these are the two primary windings or something. So they're only driving one side. I wonder what this is. Oh, of course, this is the other side of the feedback opto. There's presumably some loop compensation. Here's that little necking down I was mentioning. Also looks like there's a 330 ohm resistor to ground, which is a little odd. Maybe discharge. See, it's labeled 50 Hertz. And there are the various power connections with some series of resistors across them. 1029. Or 6201. 6.2K. I wonder if those are just discharge resistors. 26R1, that's a low value resistor. There are the little teeth, chompy teeth, spark gaps. More lettering. And then on the other side, which I mentioned, it's just the wire color code in Chinese. Except for right there, which is AC trig and then fan. That is a MVR 2060. I would assume that's also an MVR 2060. Yeah. So I mean that can only be a diode, judging from the trace of the circuitry. Anyways, that's about it. I mean, some other amusing stuff, like, so here's your input, so you have your two line, and here's the ground. So the ground actually has a, it's connected to the pad, but this is also connected straight up to that heavy duty lug, so it's like extra strong, ultra ground strapped. Also kind of interesting is it looks like there is a little metal box. Oh, this is the Kensington laptop lock slot. which just has a little box welded in over it. I guess you can't stick a screwdriver in and shock yourself by touching the power supply. That's kind of hilarious. And then there's just a little 60mm fan, which is quite nice and quiet. And here's the big clicky power button. So yeah, back together. Oy. Connector ain't coming loose by accident. Nah. See how hard it is to plug it in intentionally. So far, so promising. Making the appropriate clicky noises. These are fairly nice. Oh wow, they're even branded Rigol on the cables. It's doing the railed thing again. So, let's quickly take one of these out. These are supposedly 150 megahertz probes. That's not bad at all. Got the little kind of wanky yellow cover thing on it. So, I mean, I don't know. If it weren't for this problem, I would basically pretty much give an unambiguous endorsement, but I think that if I ground couple this to work fine. What the hell? So it just like after a while it just suddenly decides it's gonna work. I really just don't know. But yeah, so there's my you know, what is it? It's 1000 hertz, 1 kilohertz calibration input, which is just for scope probe cal. And there it is in 10x mode, which definitely needs a little bit of cal. But yeah, I don't know what to say. I mean, it just seems like it just suddenly, after it's been on for a couple minutes, it finds its ass with both hands, and then it's good to go. It's the thing that I find very bewildering is that it happens on all 4 channels, which basically means it can't possibly be anything other than like an actual design flaw, or somebody fucked up the BOM or something like that. And they stuffed a bunch of them with the wrong values, and then I don't understand why. Like, that must mean that they, I mean, like they have to all be like that. Or I mean, shouldn't their automated cal have caught that? Oh, that's interesting. Look at that. So it's currently railed, and it's distorting the portion of the waveform that isn't railed. So you can rail it a little bit, but if you rail it too hard, it fucks everything up. That's interesting behavior. And I guess the solution, of course, is to not rail it, but I guess it doesn't handle the inputs being railed very elegantly. But yeah, anyways, I mean, we're good to go. I mean, there's the internals of it. Assuming Rigol can and knows why and fixes that issue, it's definitely a nice scope, but go figure. Yo, hey, so I'm actually out at work and playing with the scope more because it still has that obnoxious issue. Sorry, this is a cell phone camera video. But one thing I've noticed that's interesting is, hang on a second. So here we are, and so if right now I'm in 10x mode, 2 volts per div, but that's really 200 millivolts. And what I have here is a sine wave with 2.8 volts DC offset on it. It's just a 1 volt peak-to-peak sine wave with a DC offset. And if I apply that, despite it acting like it's railed, as soon as I stick that negative 2.8 volt DC offset, it comes into the center. So, you know, and then I can go over here and I can, you know, move it up and down. So interestingly enough, it stays centered even as I apply DC offset, despite the fact that I'm DC coupled. Which is, well, now it's moving. So I am really not entirely certain what's going on. What it looks like to me is whatever basically like offset correction they have, which I would assume is done through a DAC internally, is not working properly. It could be a bad solder joint. I should actually open it up again to look. Or it could just be software bugs. I've tried, you know, a little bit of percussive maintenance to see if I could just kind of jiggle a bad solder joint and haven't had much luck. But interesting in any event. And the problem hasn't really fixed itself, so... Oh, sorry for the wobble cam, but I'm just holding my camera, my cell phone. Oops, where is it? Up to my microscope. But I can't say I'm that impressed with the soldering. Like, this is a an ADF4350. It's a fractional end synthesizer, which I'm pretty sure is being used for clock generation. When you consider it's then routing into this main device, which I'm 99% sure is the ADC. But one of the things you'll notice is, look at these fillets. It doesn't look like, where's my pointer? It doesn't look like they've actually flowed up onto the package and filled in like they should. So I can't say I'm too impressed with the soldering. I'm just kind of looking over, trying to see if I can find any bad any obviously bad joints. I found a few. Let's see if I can manipulate this. Like a couple joints. It's out of focus. Like, we have 4 of these devices here, which I'm not sure what they are, but a number of these joints look like they're slightly cold, but I pressed on them and they don't move too much. So it could just be a fairly light solder joint, but it's still a good one. But I'm just looking over, and yeah, I'm not too impressed. So we'll see what I find. Well, I have no idea what happened, but I put it back together, turned it on, and we now have apparently correct Y offsets. So, well, and with the case back on, it's gone to shit again. So whatever it is, it's definitely a mechanical stress. It's a bad connection somewhere, because just putting the case back on is enough to cause it to shit itself again. Rather irritating. I don't really want to spend time trying to fix it today, is what it comes down to. I'd rather just try and get warranty support on it. I mean, I did unfortunately not quite get the warranty void if removed sticker back together, but you know, hopefully they'll not be that horrible. So I can kind of just walk through the situation.